Hello. In this video, I want to introduce the virus framework that I created, which packages everything you need to create and research viruses for Linux. You can find a link to the repo in the channel description. This is a pretty big project containing lots of pieces, so I think it will be good to talk about the motivation first, and then look at some of the code at a high level while discussing why they're important to creating a virus. There are lots of blogs and videos online you can gather bits and pieces on novel infection algorithms or exploits, but they typically have something in common. It's usually non trivial to reproduce interesting algorithms and play with them right out of box. The authors may or may not share the full source code, compilation commands for things to work. Sometimes the code was written in a non portable way, targeting only a single architecture. You would need to pour a massive amount of time and resources to reuse things you found. The virus framework aims to change that by providing building blocks that work out of box. It ships infection algorithms and a version of libc that is virus friendly. Most importantly, the build system is set up in a way that is hermetic and reproducible. Whatever works on my machine would work on your machine, on your mom's machine, and on your cat's machine if it has one. Let's take a quick look at the framework and why some of the building blocks can help. First off, you heard me right that the framework ships a version of the libc. It's called nostdlib. The reason is that the popular GNU libc uses global variables and RO data, which viruses cannot use. If you have watched other videos in this course, you will know that a virus needs to be injected into other programs, so they have to be self-contained with no linking to external libraries. Because viruses don't get the luxury of locating code from shared libraries dynamically. In addition, the virus we write must not refer to .data or .ro data sections. From high school CS classes, you'll learn that .data section is where global variables live, and .ro data section is where constants live, like string literals. As you can see in this elf header dump, the RO data and the data sections are pretty far away from .text section. Typically, a virus is injected as a whole binary blob into a place that has executable and readable permission. This virus will have a hard time finding places that is readable, writable, and executable for its .data section. Also, RO data takes a fair amount of space. It's best to avoid it. To address this, we have a special version of the libc. It's ported from Linux kernel's nostdlib, but rewritten in C++, providing most of the things a virus could use. Here is the standard header. We have the exact syscall, which viruses can use to run other programs. Fork, which can be used to hide and run malicious code in a new process without affecting user experience. Of course, standard file operations like ftruncate and unlink that might be useful for ransomware. These are actually wrappers. When you click on any one of them, you will jump to an anonymous helper function that uses a syscall macro. This macro is a syscall wrapper. My syscall2 means it's going to call a syscall with two parameters. All we need to do is to use the right syscall number. This blob of inline assembly takes care of the rest of the arguments for you. So it's pretty straightforward to add support to other syscalls. You should also notice that this entire function call path doesn't involve error number that you're familiar with. It's usually a global variable, and we purposefully do not want to use it. Just avoid touching the .data section. Let's rewind back. We have other good stuff that's pretty commonly used by viruses. For example, the mmap that allows a virus to inspect files by mapping them in memory. This mfd create syscall. It's a trick to create something called fileless virus, which doesn't leave any trace on your file system. It makes forensics hard, and we'll have a video dedicated to it later. I recently added socket support so we can research networked viruses that can plant backdoors or expose a reverse shell. I encourage you to poke around the repo and see yourself. The way to use them is pretty simple. In this example virus, you'll include a no stdlib headers and invoke syscalls in our VF namespace. And that's it. After you build the virus, you should not see any RO data or data section generated, so you can inject this example virus to any program without a problem. How the build system works and what this string literal is are topics for another day. If you like the contents here, please like and subscribe. If you want to learn more, I'm putting together a full course on virus engineering. Just check out the links in the channel description. Have a good one, and I will see you later.